Hello friends, today we shall discuss about clinical chemistry, and when we talk about clinical chemistry, the main component will be biochemistry. We'll just walk through the different methodologies of biochemistry today. To start with, colorimetry and photometry turns out to be the first type of analysis. Then comes turbidometry, and we also have ion selective electrode, and we have immunoassay. We'll discuss about each of them in detail now. To start with, colorimetry and photometry, they run on the same principle, which is Beer-Lambert's law. What Beer-Lambert's law say to us is the concentration of the chemical which is in a distinct color will decide the absorption of light passing through it. If I need to change my words and say a monochromatic light, which means light of one particular wavelength, if it passes through a colored solution, the amount of light that is absorbed is directly proportional to the quantity of color. If there is more color, more absorption will happen. If there is less color, less absorption will happen. And also, it is inversely proportional to the path or the length. And in a typical biochemistry scenario, the path or length will remain the same because that will be the width of the cuvette or the test tube. So the concentration of the color is directly proportional to the absorption of the light. And next we'll see the basic mechanism or the skeleton diagram of a colorimeter or a photometer or a semi automatic biochemistry analyzer. Here we see there is a light source. The light source will emit light, and there will be a lens mechanism which will convert the diverging light into a pencil beam, because when light is emerged from a bulb, it will go through different directions, and here we are supposed to have a light which will pass in one direction. For that we need a lens mechanism. Then comes a filter. Filter, what it does is it will absorb all the other colors and let only one color light pass through. Then comes the cuvette. Cuvette is the place where the actual analyte will be, and after that there will be a measuring mechanism which will analyze the quantity of light that is falling over here. Here the quantity of light that comes here is directly proportional to the concentration of color in the cuvette. That is colorimetry. Even photometry is the same, but the only difference is in photometry, it is not only the visual light but also UV light. That's why in photometer you will find even the UV range, which is a typical 340 nanometer range in a normal photometer. Now we'll just see what are the kinds of chemistries. There are three types of chemistries in a photometry. One is the endpoint chemistry. What an endpoint chemistry is, what is the color of the entire analyte after the reaction is over. Generally, we use it for tests like glucose in GOD-POD method, where the color will develop over a period of time, typically 2 minutes or 3 minutes, and after the time is over, we will measure what is the final concentration of the color. Next comes the fixed chemistry, or in fixed time chemistry, how much color is developed in a particular period of time, typically between 1 minute and 2 minutes, what is the quantity of color that is developed. So if more quantity of developed during this time, that means there is more concentration. If less quantity of color is developed during this time, that means there is lesser concentration. And then comes the kinetic chemistry. In kinetic chemistry, the ratio of the change of absorption over a period of time is analyzed. In this case, if you see after 5 minutes, whether you have less concentration of the analyte or more concentration of the analyte, the end result will be the same. So here we measure how fast the analyte is able to change the absorption, that is kinetic. Kinetic is generally used to measure SGOT, SGPT kind of chemistries. Then comes turbidometry. So what is turbidometry? Turbidometry is very similar to photometry or colorimetry, but here the only difference is the color is not changing here. Here the light source will remain the same, the optics will remain the same, the filters or the monochromator will remain the same, but here we analyze the amount of light that is deflected or deviated from here. Here the analyte will turn turbid. Turbid in the sense it turns more milkier, or it will start absorbing more light if the analyte concentration is more. If the analyte concentration is less quantity of light is deflected. If the concentration is more, then more quantity of light is deflected. And here the measuring principle remains the same as in other biochemistry analysis. So this is pretty much about the turbidometry. Turbidometry in a definition is measuring the loss of intensity of transmitted light due to the scattering light. So, and we'll discuss about the remaining two in the next video.